All right, so now let's solve some examples. So is assume that a factory has two machines. Past records. The factory has two machines. Past records show that machine 1 produces 30% of the items of output, and machine 2 also produces 70%. Further 5% of items produced by machine 1 were defective, and only 1% produced by machine 2 were defective. If a defective item is drawn at random, what is the probability that the defective item was produced by machine 1 or machine 2? You have to find the probability that the defective item was 1 or machine 2. Now let's extract key information from the question. So from the past, we know that, so that's what we believe. That's what we know. That's our initial what that for machine 1. So probability that machine 1, we are looking at the total number of items that the machine 1 produced is 30%, which is also 0. And that of machine 2, 70%, 0.7. Now, we've been given that whether 5% of items produced by machine 1 were defective. So we've been given that half as probability of defective, given that it was produced by machine 1. That's what we already know. We already know that if we have a number of defective items there, then the probability that this defective coming from what machine 1 is also 5%, which is 0.05. Also, if it is defective, given that it is coming from machine 2, only 1%, which is 0. Now, what are we to find? We have to reverse what we have. Now we have to find probability that we have machine 1 as output in that effective. We don't know. That's what we want to find. And also, we have to find output given what effective. We don't also know that one. Now let's find the first one. Probability. Machine 1 given that the base here, reverse it. What we know, effective that machine 1 times what we know, that's our initial, that's our power probability 1, divided by the total probability as effect, equal to probability of the given M1, probability of defective product or item given that is coming from M1, 0.05 times 0.3, that's this, divided by, now we want to find the total number of defective items. So now we have two machines. We have to find the total number of defective items coming from machine 1 and that of defective item coming from machine 2. That gives us the total probability. How do you do that? Basically, 0.05 times 0. That's the trick. So if the one we are finding, though, is at the numerator. Now, if you want to find the total, we bring the numerator down. That's for machine 1. Then we have to find that of machine 2. Have 0.01. 0.01 times 0.7. 0.05 times 0.3 divided by 0.05 times 0. Plus 0.01 times 0.7, which is giving us 0. Also, for machine 2, machine 2, that is from perspective. We have to reverse it. That's what we know. We already know it was given time ability to divide by our total, that's our total effect. Now we also know that effective, given that it is from for 0.01 times that of machine 2, 0.7 divided by here too, we have to bring the numerator to the that is my as we go in for that of my 1, 0.05 times 0.3. 0. Have 0.01 times 0.7, 0.01 times 0.7 plus 0.05 times 0.3, 0.3, and alternatively, we can summarize this in a table form to find the answers. Table form to find answers. And let's do that. So we have event. My event is 1. And we have our initial belief, what we already know. That's our prior probability for our prior probability for machine 1 for 0.3 and 0.7 respectively. 0.3, 0. We also have conditional probability. Take note, we have two conditional probabilities here. This one for machine 1, that one for conditional probability. Machine 1 is 5%. 0. Machine 2, 1%. And the next thing this is the information provided. Now the next thing we have to do is find the joint probability. Joint probability. How do you find your joint probability? Your joint probability, multiply 0.3 times 0.05. So 0. For machine 1 and this one also get your joint probability. For the first one, 0.3 for machine 1, 0.3 times 0.05, which is 0.015. And for machine 2, which is 0.7 times 0.01, 0.01, 0.007. When you get the joint probability, find the total. Find the total. So 0.007 When you are done, we are now coming to solve our revised probability. What we are interested in, or the posterior. This gives us the what? The answers for the what? The Bayes theorem. How do you find that? So we pick the first one and divide by the total. We also pick the second one and also divide by the total. That is what I mean. First one of the joint is 0.015. Divide by the total, which is 0.015 divided by 0.02 and 0.6. When you check with the previous one we did, you are getting the same answer. For the second one too, 0.007 divided by 0.02, 0.007 divided by 0.31, getting that. So at the end, make sure that your revised or posterior equal to 1.00. Now you can add 0.682 as 0.318 as total probability 1. All right, now let's get into the next question. Next question. In a boat factory, machine A, B, and C manufactures 25, 35, and 40% of the total output respectively. Meaning that for machine A, it manufactures 25, machine B 35, and machine 40. Of the total of their output, 5, 4, and are defective. A boat is drawn at random and is found defective. What is the probability that it was manufactured by machines A, B, or C? So here I would use the summarized form as in the table form first, then we'll use the formula of it, whether we are going. For the first one we have to do, let's identify our variables. In a factory, machines A, B, C manufacture 40% of the output effectively. That's what is known as in what the machine A, B, and C what they produce. So that's probability. So let's say probability that A produce probability of 25%. That of machine B, which is 35%, 0.35. Lastly, 40%, 0.4. Now, for the second sentence, out of the total, out of the total of their output, 5% are effective. So we already know that if this output are produced by them, the percentages 5, 4, and are defective output. So now you already know, and they've given us that probability that it is what defective, and it is coming from machine A is 5%, which is 0.05. Probability that it is defective come from machine B 4%, which is 0.04, and probability that it is defective and it's coming from machine C is 0.0. These ones are the conditional probability. Now let's put them in a table form. Now we have machine. We have machine 1, that's machine A. We also have what my initial belief, higher probability for A was 0.35. And we have the conditional probability for A 0.05, 0. How do you find the joint probability? Pause the video, try it yourself. How do you find the joint probability? Alright, so the joint probability is actually your prior probability, conditional probability. This one is 0.2, 0.05, 0.015. And for the second one, 0.35 times 0.014. And for the third, that's machine C, 0.4 times 0.02, 0.00. The next thing we have to do is find the total of the joint probability. 0.008 plus 0.014 plus 0.125, giving us a total of 0.035. Now let's find what we are required to find. That's what we don't know. Is the posterior probability or the revised probability. How do you find the revised probability? Take for the joint probability. First one divided by the total. First one is 0.0125 divided by 0.035. 0.0125, 0.36. Next one is 0.01 divided by the 5. 0.0. Last one, which is 0.008 divided by 0.45. 0. And when you add probabilities, 1. All right. Now we are being asked find what is the probability that it was manufactured by machine A. Machine A 0.036, machine B 0.406, and machine C 0.2332. 0. Now try using formula to solve whether you will get the same answer as table, your table. Thank you. Don't forget to subscribe.